You're in the middle of a critical measurement. The tolerance is tight, the part is clamped down, and suddenly, the digital screen on your calipers blinks and dies. The battery is dead. The manual vernier caliper requires no power and never runs out of battery. It relies on sliding steel and optical alignment to measure down to a fraction of a millimeter. We are going to walk through the process of measuring a workpiece, or a job, from the initial setup to calculating the final decimal value. Learning to read this dual-scale system bridges the gap between using a standard ruler and operating high-end metrology equipment. Step 1 is preparation. Before you take any measurement, wipe the measuring jaws clean and close them completely. Even a microscopic speck of dust can ruin a reading. Now look at the scales. The 0 mark on the small sliding scale needs to line up exactly with the 0 mark on the fixed main scale. This maintenance diagram explains the light test. You check the closed outside jaws against a light source. If you see light peeking through, the jaws are sprung or bent, making an accurate reading impossible. If the 0 marks do not align perfectly, the tool has a 0 error. You must note this offset value now, because you'll subtract it from your final measurement at the end of the process. Measurement accuracy begins with the physical state of the tool, well before you ever apply it to a piece of metal. This diagram shows the 3 ways the caliper interacts with a part. You use the large lower jaws for outside dimensions, the smaller knife-edged upper jaws for inside diameters, and the thin rod extending from the back for depths. Slide the jaws onto your workpiece. Use light, consistent pressure. Squeezing too hard deflects the steel jaws outward, which creates an incorrectly small reading. These operation images show the correct grip. Use the thumb wheel on the bottom to dial in a snug fit. Once properly seated, tighten the lock screw on top to freeze the slider in place before you remove the tool to read it. Ensure the jaws are perfectly perpendicular to the object. If the caliper is tilted, you end up measuring a diagonal line across the part, which is longer than the true dimension. Proper physical handling translates the physical object into a stable, readable position on the scale. This diagram illustrates the dual scale system. The fixed upper scale gives whole millimeters, and the sliding scale provides the fraction. Locate where the bottom 0 lands on the top scale. Here, it passes the 1 millimeter mark, so our main reading is 1 millimeter. Do not take this reading at the physical edge of the sliding jaw. Always read from the 0 line printed on the scale. Now we find the fractional part of the measurement. Start at the 0 on the bottom sliding scale and scan your eyes slowly to the right. Find the single bottom line that perfectly aligns with the top line, creating a continuous vertical mark, as shown by the red arrow. The tool's printed 0.05 millimeter least count means each bottom tick is 5/100ths. The 7th aligned line equals 0.35 millimeters. You must look directly down at the scales. Because the sliding scale is slightly raised, looking from an angle creates parallax error, which makes the wrong lines appear to align. The vernier scale leverages the human eye's natural ability to detect when 2 line segments are perfectly straight versus slightly staggered. Step 5 is simple addition. Take your main scale reading of 30 millimeters and add your vernier reading of 0.35 millimeters for a total of 30.35 millimeters. Returning to the first diagram, the main scale shows 1 millimeter. The 9th mark on the bottom scale aligns perfectly. 9 multiplied by the 0.05 least count gives us 0.45, resulting in 1.45 millimeters. If you identified a 0 error at the start, apply it now. Subtract that initial offset from your final total to find the true measurement. Manually calculating this number ensures you understand the physical relationship between the jaws and the increments of the scale. The final reading represents the combined accuracy of your preparation, physical grip, and optical alignment. The sequence is always the same. Clean and 0 the tool, secure the part, read the main scale, find the aligned vernier mark, and add. In a workshop, this process becomes muscle memory, allowing you to verify parts against technical drawings quickly and accurately without relying on electronics. Build your confidence by measuring objects with a known size, like precision gauge blocks or the shank of a drill bit, until your manual readings match the stamped dimensions. The principle Pierre Vernier published in 1631 still provides 0.02 millimeter precision using nothing but etched steel and eyesight. Mastering this tool provides a level of mechanical independence that digital sensors cannot replicate.